Everybody, it's Miss Phoebus and I'm back with day 11, Algebra 1 EOC review. So here is problem number 38. Alright, this is the lesson that we are going to be cutting out before the end of course, and we'll talk about it after the end of course. It's actually one of my favorite lessons because there's not a whole lot of math involved, but we have this idea of correlation, right? How are the variables related? And a lot of times, like things like, I don't know, number of cigarettes smoked that somebody smokes and their chances of getting cancer, a lot of times people always associate those two variables with one causing the other, right? You're more likely to get cancer if you smoke more cigarettes. So we start dealing with those things, the correlation, the relationship between the two variables isn't necessarily a cause and effect type relationship. And so would we have a causation between those two variables? And so that's what the whole entire lesson's about. And just because things are correlated does not mean that it is, one causes the other. So the way that the saying goes is correlation does not imply causation. So just because two things are close does not mean that one causes the other. The other part of the lesson is, well, if we do want to show that something causes, one variable causes another variable to happen, or causes it to change, I should say, then we have to run an experiment. And so we would need to look at lots and lots of different settings and different people involved and things like that. And does one affect the other? This question isn't necessarily about experimentation to try to figure out the causation relationship, but really looking at the variables, if you were going to say one thing has a direct effect on something else, then which would be the best relationship? So if we look at this, a person's age and his or her shoe size, well, just because they are younger doesn't necessarily mean that they have smaller feet, and just because they're older doesn't necessarily mean that they have larger feet. So, because I've known plenty a young teenage boy that has much larger feet than me. So a person's age and his or her shoe size is not necessarily a good causation relationship that their age necessarily affects their shoe size, that it changes it. The number of ice cream cones sold and the amount of sunscreen sold, this is also not a good causation relationship because ice cream should not have any effect on sunscreen, and that is what we call a lurking variable or a hidden variable, that ice creams are probably going to sell more and sunscreen are going to sell more on hot days. And so the temperature of the day and how much sunshine and all of that would have an effect on ice cream cone sales and sunscreen sales, but not necessarily true because if you go in and you talk to anybody that works at a McDonald's or a Dairy Queen, they sell pretty much just as much ice cream on some of the cold days as they do on some of the warmer days. It just kind of depends on the person that's buying it. All right, we're going to skip to S because that is also not going to be a causation relationship. The baseball game is not going to last any longer or shorter based on the number of people that are attending. So, and the people that are attending aren't going to affect the baseball game. So those two are not really going to have an effect on each other. Yeah, they kind of go together and it can kind of, you could maybe even collect data on it, but one should not cause the other to happen. which takes us back to R, the temperature at a football game and the number of hot drinks sold. So this is different than P because we actually have temperature involved, and if temperature is cold, then you're probably going to sell a lot of hot drinks. If temperature is warmer, then you're probably not going to sell as many drinks, and so that temperature is going to have an effect on the number of hot drinks sold. And we could run an experiment, we could collect data, we could send somebody out at the concession stand every single week and we could count the number of hot drinks sold, and we could measure the temperature, and I'm pretty sure we could collect data on all of these, but we should be able to see that temperature is going to have an effect on the number of hot drinks sold. So R is going to be the best answer for this one. And again, it goes into that piece that we haven't talked about yet, but that is what a causation or a causal, C-A-U, let me write this out. A lot of times people read this as something else. A causal relationship is one where one causes the other to happen. That is not a casual relationship. A lot of times people flip the S and the U around. So that is another word that could be brought up when you're discussing this. All right, this is question number 39. All right, we're going to select all the tables in which the y value changes at a constant rate per x interval. So a constant rate of change is a constant slope. We're looking for an arithmetic sequence where we're adding or subtracting the same number each time. And A is definitely going to be one of those. We're adding 0.5 each time. So we should choose A. We are not going to choose B because you're adding 3 here and 5 here and 7 here and 9 here, and that ends up being a quadratic if you look at your second differences. 2 to 4, 4 to 8, 8 to 16, 16 to 32 is a geometric sequence, which means that it is best modeled by an exponential function which has a constant factor, not a constant rate of change. Here in D, we are subtracting 3, subtracting 3, subtracting 3, subtracting 3. We're going to choose D as an option. Here we're going adding 7, adding 19, adding a whole bunch more. Guess what? E is not. E is actually a cubic function. If I take 2 and cube it, I get 8. If I take 3 and cube it, I get 30 or 27. If I take 4 and cube it, I get 64. 5 cubed is 125. So this is a cubic function. All right, so your answers are A and D. Here's problem number 40. All right, so this one, what I would do is I would start solving for that BX piece and then kind of use my imagination, use my deductive reasoning skills to help me figure out what should be B. The first thing I'm going to do, though, is this is written backwards. I'm going to flip this around. So I'm going to make this BX plus 9 is greater than or equal to 51. Now, why did I change the sign? Well, I want it to still point to the 51. So if I don't have it still pointing to the 51, it's not going to be correct. The next thing I would do would be subtract 9. So BX is greater than or equal to 51 divided 51 minus 9 is 42. Now notice that my signs are the same. So what would I divide 42 by to get 7? Well, dividing by 6 would get me a positive 7. So B would need to be 6. So B is 6. Here's problem number 41. All right, so which system of equations has only one solution? So you could do a couple different things and you could graph. These are two lines, there's another two lines, here's an absolute value in a line, here's a quadratic in a line. So you could graph each and every one of them. But I'm going to go ahead and tell you there's an easier way to do this. If I'm graphing two lines, they're only going to have one solution if the slopes are different. And P, the slopes are the same. So that's not going to work. M, the slopes are different. M is going to be my option that I want to choose because that's only going to have one solution. These are going to imply, because I have a quadratic and I have an absolute value, that it could cross more than one time. And so because I have an absolute value and a quadratic, I have the potential of crossing those functions more than one time, and I'm looking for only one solution. So let's break out the calculator and let's see what it would look like if we type these in. I'm going to start with the quadratic and then the absolute value. So go into y equals x squared minus 1 and 1.5x plus 1. And definitely crosses more than one time. There are 2 points of intersection. If I go back in, just to 0.2, and then I need my absolute value. So I'm going to hit the green button and then the window button, and there it is, absolute value, my abs. And I want x minus 5 inside, and I'm going to graph that. Definitely crosses more than one time. If I go and I graph x minus 2 and x minus 2 and x plus 4, I'm going to see I have parallel lines. Parallel lines will never cross. And if I have, I should have kept my x plus 5. X plus 5 and negative 3x plus 6. Then I have 1 point of intersection. So my only concern is if this is on the graphing calculator portion, not a problem, right? You could type each one in. But what if it's not on the graphing calculator portion? What if it's on something that is, you have no calculator for? So could you tell? And definitely if you have two lines and the slopes are different, you're going to have only one solution. So that's an easy way to tell. If you do know that and you have a calculator, then you've just saved yourself a whole bunch of time as well. All right, here's problem number 42. All right, we know it's a geometric sequence. We have the recursive formula. And the thing for the geometric sequence is that you do not have to memorize the explicit form because it's actually on the reference sheet. You just have to go back and use it. So a sub n equals a sub 1 times r to the n minus 1. Now some of you may be like, well, I don't know where to get a sub 1 and I don't know where to get r. Well, you're going to get them from the recursive form. Here's a sub 1, here's r. That's it. You just need to pull them into the right form. So a sub n equals 5 times 7 to the n minus 1. You're done. So again, personal fan of things that look terrifying, but actually aren't that bad. All right, guys, that's it for today's EOC review. I'm hoping you're finding this helpful. It's jogging your memory, and it is bringing up maybe some questions that you have. And if you want to drop into my Google Meet, you are more than welcome to do so, and we can talk about things. All right, I'll see you guys in the next video. Bye.